Hello everyone, let's dive into the world of RAG. But before we jump straight into what RAG is, let's start from the start. Like what is happening now? Like in today's stack, we are familiar with giving queries to LLM model like LLM and receiving the responses, right? Like here we give the query to LLM and LLM will give us the response. Now, if you are struggling to visualize this, think of it this way. Like imagine having a conversation with ChatGPT and getting the responses because you know ChatGPT is also a LLM model. Okay, now you must be thinking, what is the problem here? Like we don't see any problem here. So here is the catch. This is the problem. Everything seems pretty good with LLM. There is a little issue. Like LLM doesn't work when it comes to handling unseen or personal data. Like, have you ever tried throwing a personal question to ChatGPT? Like asking about your favorite ice cream flavor or your weekend plans? Well, chances are that it won't have a clue. Why? Because it's not trained on your personal data. Okay, so it's not trained on our specific data. But here's the thing, like we all want a model that knows us inside out, one that can handle our personal data. If we give our information like who I am, what I do, and other stuff, then it can handle those things properly. Let's not forget about the companies out there because they have so much confidential data and they don't want to share it with anyone. But they all want a model that can work on their confidential data because each and every LLM model trained on a generic data which is either present on a web or not confidential. Now let's see the solutions. Here we have three solutions. First one is training, second one is fine tuning, and third one is RAG. Let's talk about training. Training is like starting from the scratch. We have a model, we have our data, and we train our model according to our data. So from on our data, so we give the model new data it hasn't seen before and teach it everything from the ground up. And in fine tuning, we'll take any pretend LLM model and modify it according to our task. Okay, let's take an example for simplifying this. Training is like teaching a robot from a scratch, well, fine tuning is like enhancing the skills of a robot that's already pretty smart. Here are the some things that you should know. Like both training and fine tuning takes a lot of time and resources. Like in training, especially for the big models like GPT, can cost million of dollars because it needs so much data and computing power like GPUs and all. Fine tuning usually faster and cheaper compared to the training. So yeah, that's about the fine tuning and training. Let's talk about the RAG. Take step-by-step approach to understand RAG. Starting with the basic, we gradually explore deeper layers with each part. It's like peeling an onion, revealing more as we go. So here is the part one. Like it's a standard scenario. Like we are giving the query to LLM and LLM is giving the response. But in case of RAG, we are just adding one layer. It's called context. We are not only giving the query, we are also giving a context to LLM, and then LLM is giving the response. Yeah, like it's a big picture of RAG. Right, let's talk about the this context part. This context is basically unseen data on which you want your model to work on. So we are basically telling the model, hey, use this info to answer the question. It's like giving a smart student a book and saying, find the answers in here and write it down. So we are letting our model to read through the context and come up with the answer based on what it finds in this context. So till now we were facing issue with the unseen or personal data that we can resolve with the context. Like we'll give the context directly to the LLM and LLM will answer those questions related to that data or the context. Now here is a little problem in that, like you cannot give all the data or all the context to the LLM because in companies there can be huge data like in TVs or GBs as well. So we cannot give the whole data to the LLM. Why we can't give that whole data to the LLM? Because as you can see here, our context and query both are going in a prompt to the LLM. Like we are giving a prompt with the query and with the context. So but in each and every LLM there is a token limit, there is an input limit. Like as you can search here, token limit for GPT 3.4 turbo, there is a token limit of 4096 tokens. Think we can only feed these number of words in the GPT. That's why we cannot feed all the data at GPT or any LLM model. Now we know what are the problems, like LLM can't remember too much information, and there is a input token limit, which I have shown you, and there will be hallucination. Let me tell you about hallucination. Hallucination means it will give you random answers because it got lost after getting too much information. So let's talk about the solutions. In the solution, will not give the whole data. We'll extract the relevant chunk of the data from the whole data and feed it to the LLM. Okay, let me give you an example here. Let's suppose this is the data which is containing all the data regarding to Shyam, Ram, and Mohit, and this is the query. Like our customer is asking about tell me the name of Ram's father. So as you can see here, we only need the information around Ram. Like as you can see here, we only need the information about Ram. Then why we need to feed all this information of Shyam and Mohit? That's why our relevant data will be Ram. We will extract that relevant chunk of data from this whole data and will feed it to the LLM with our query, and it will give our answer. Now I guess you got to know about the whole picture. So this is the whole picture. As you can see here, we'll get a query, and according to query we'll extract the relevant chunk, and this relevant chunk and the query will go to the LLM, and then we'll get our response. This is the whole picture. Now we'll go deeper into that, and you must be thinking about the process to extract the relevant chunk of data. So we have our data and we have our query. Now they both will go through the same embedding models, and as an output we'll get the embeddings. Embedding models basically convert the text data into the embeddings. Now the embeddings of this whole data will get saved into the vector database, in which we'll do the similarity search with our query embeddings, and we'll pick those embedding vectors that are closest to it. Like we'll take this embedding and we'll do the similarity search in this vector database, and we'll get the closest embeddings, the matching embeddings, and that's how we'll get the relevant chunk of data from this. Now let's move to the final picture. That's how it will look. Like customer will ask question or slash query, and it will go through the embedding model, and from embedding model we get the query embeddings, and those query embedding will go to the vector database where all the data embeddings will be present. Here similarity search will happen, and we'll get only those embeddings those are similar to our query embeddings, and that's how we'll get our relevant context, and then this relevant context and then this query both will go to the LLM and we'll get our response. That's how the whole RAG works. That's the picture of the whole RAG. And in our next videos we'll do some implementation on the RAG. Thanks for watching.